Hello everybody, welcome to our class number 9. Today we're going to be talking about SQL joins. Today we're going to learn how to connect to the database, build a diagram, describe the database, learn about SQL joins, and explore data in a database. So what is SQLLight? SQLLight is a serverless database, and it's arguably the most used database engine in the world. And the reason for that is because it's built into all mobile phones and most computers. So when you use your iPhone or Android phone, data in those phones is stored inside SQLLight. So it's open source, it's free. And it's used also on the servers and for the websites in many different ways. So it's one of the most simplest databases and one of the most used. Arguably the most used. Every Android device, every iPhone, every Mac, every Windows machine. So it's used a lot inside applications, TurboTax, QuickBooks, and so on and so forth. So we use it because it does not require us to use any servers and networks, so that we can actually use it in our class without any issues. Inside the data folder that comes with this class, you will find a file called chinook.db. This is actually a database that we'll be exploring. To start using the database, we're going to use our dbviewer, right-click, create connection. Here you're going to pick SQLLight as our connector, as our database. Click Next. Now it will ask you about the path. You can open, go to a directory where you save the file, and select the file. Click Open and click Finish. And we are done. So now we can start exploring the Chinook database in SqlLight. Now that we connected to our database, let's create an ER diagram. ER stands for Entity Relationship Diagram. What it means, I'll explain a little later. So you say create new ER, so under diagrams, right click, create new ER diagram. You select the database we did and just pick tables, all tables, and give a name for the diagram. Let's call it Chinook DB, something like that. And click Finish. So dbviewer automatically creates a very nice looking diagram that we're going to start exploring. Let's start exploring our database. What you see on the right is first table we're going to look at is employees. So this table, think about it as our Excel worksheet. It represents employees. So here's basically we'll have a first name, last name, title, and so on and so forth. Let's create a script. So to create a script that we can start working with, you right-click on the database, SQL editor, and you click New Script. And let's save the script. See, now by definition it created a script file with name script. I'm going to click F2 and rename it to 01 employees. As we progress through the lesson, we just have different scripts that we're going to play with. So this is basically creates a file, 01 employees. So let's look again to our ER diagram. And we can see that we can see basically what employees are, last name, first name, title. So let's just look at the data. So to do that, we're going to do select star from employees, and this E we don't really have to have. And this gives us a list of employees we have in the system. So what's interesting about it? Basically, we see ID as the first column, last name, first name, title, and so on and so forth. The only kind of interesting column here is reports to. We're going to look at what this column means, and employee ID. So we're going to look at these two columns next. Let's select a little bit less number of columns that actually are of our interest. We can put employee ID, last name, first name, reports to, from employees. So now when we see subset of columns, the first field, employee ID, when you look at the property of this table, it has a little key right here, and under keys it has primary key. This key means it's a primary key. Tables have primary keys, and basically primary key is the ID of the row. This is the fastest way to search for the record. So for example, if we would say select from employees where employee ID equal to 1, the search is called by primary key because we specify in our search the primary key. Right now we only have a small number of records, so we cannot really see the difference. But if we would select for example, where last name equal to Adams, if we would have a lot of rows, this query would take a lot longer than if we would select by primary key. So primary key is basically uniquely identifies the row. So each row in each table has a primary key. So second column I want us to look at is column called reports to. As you can see, Adams Andrew has reports to value null, which means nothing. So it does not have any value. And Edwards Nancy has value 1. So what this value means here is that Edwards Nancy reports to employee ID with ID 1, which reports to Adams Andrew. And you see Michael Mitchell, right? He also has reports to 1, which is also reports to Adam Andrew. So basically, this is kind of a hierarchy of who reports to whom. So if we would say select from employees where reports to is null, basically we're saying give us our top manager. The top manager is Adam Andrew, which is ID 1. Then we want to see who reports to Adam Andrews. Adams Andrew, we can say, okay, select from employee ID where reports to equal 1. So Edward Nancy and Michael Mitchell. So Nancy Edwards and Michael Mitchell reports to Adams Andrew. If we can see that actually Jane Peacock and Margaret Park, they report to employee number 2. Employee number 2 is Edwards Nancy. So now we can say, okay, select from employees where reports to equal to 2. So now we can see that these three employees report to employee ID with ID 2. So Jane Peacock, Margaret Park, and Steve Johnson. If we want to show the manager and his employees, you can say employees reports to 2 or employee ID equal to. So in this particular case, we can see that employee ID equal to is Edwards Nancy, and people who reports to is Jane Peacock, Margaret Park, Steve Johnson. Steve Johnson report to Edwards Nancy. Let's look at our diagram again. Let's look at these two tables, employees and customers. So customers are obviously the list of customers, and you can see here is a line between these two tables, employees and customers. This is called relationship. It's something similar that we saw in Power BI. Power BI or Excel. So if you click on this relationship, you'll see two columns highlight: employee ID in employees and supported rep ID in customers. Basically, customers have supported rep ID of employee. Means supported rep ID will have ID of the employee that supports this customer. We're gonna right now explore this relationship, explore customers, and then explore relationship between customers and employees. Another interesting column here is customer ID, primary key. So this is again ID that uniquely identifies each customer. So let's create another script. So we're going to right click on our database, SQL editor, and new script. Let's rename the script again to, let's call it 02 customers.SQL. Okay. So now let's start exploring the customers. So let's start from customers. Okay, so what we can tell is that we have 59 customers. And here's all the records, all the table records that we have. So we can see that some of the customers are business that have company name, and some of them have company name null, so meaning residential customers. We have addresses, city, state, some states are empty. We have a country, phone, fax, and so on and so forth. So let's kind of play a little bit with this here. What kind of accounts we kind of interested in? Let's do customer ID, first name, last name. Let's do company, and I would say country and support rep ID. That's something that we have an interest in. So let's run this query. Now we have less columns to look at. So if we want, for example, to look only at business customers, we can say where a company is not null, meaning not empty company. So this will give us 10 records of business customers, or if we want to only look at residential, we can say is not. This will give us 49 records. So That's good. Let's copy this statement here. And you can see that we have support rep ID is 534, right? It's not very clear who is really employees that support this particular customer. So let's kind of filter out saying, okay, where support rep ID is equal to 5. If we select statement and enter, it will only execute this particular statement. So now we have all the customers that sales rep ID is equal to 5. But we don't know what the sales rep ID is equal to 5. Well, let's look at information select ID, select employee, let's start from employee, where employee ID is equal to 5. We don't necessarily do this. So let's look which employee is it. Okay, so it's basically Steve Johnson. So by running these two queries, we can tell that Steve Johnson, one employee, is supporting these 18 customers. Let's look at our ER diagram. And what you will see is this relationship between employees and customers. You see this fat dot next to customers, meaning that one of these employees supports many of these customers. So if we want to, from this query from customers, if we want to display not just ID of the sales rep, but we want to display the last name and first name of the employee, we will do an operation called join. So join meaning that join the result from two tables, from customers and employees. So to do that, we're going to type join employees. So now, as you can see, this says customer C, employees E. This is like an alias to make query shorter. So once we do join, we need to show how those two tables know about each other. We can say on employee ID equal to customer supported rep ID. Basically, it says this is what we did manually. We're going to look at for each customer with supported rep ID. We're going to look by that supported rep ID, join the employee table, and pick the values from that table as part of our result set. So we also need to say which columns we want to show. So you say E dot first name, E dot last name. So now let's try to run this query. So now, what's interesting is we have first name. There is a column first name in both tables, in customers and employees. So we need to prefix all the customers fields with alias C. C dot, right? To basically to tell SQLLight from which table this column comes from. So let's try to run it now. And now it works. So, but it's still not very good result because, as you can see, we see first name, last name, and first name, last name again. Not very clear. This is first name, last name of customer or employee. So it's better to add alias. Let's say as customer first name And this one we're going to rename as customer last name. And this column we're going to rename as employee first name, as employee last name. So now we have this query. Let's try to run it. So now the result is much nicer. We can say, okay, that makes sense. We have customer ID. We have supported rep ID, which is employee ID. We can rename supported rep ID as employee ID. So now we can tell, okay, we have customer ID, customer first name, customer last name, we have a company, and all that was supported where supported rep ID is 5, right? So if we want to change query, still not very easy to read, we can say where employee last name is equal to Johnson. So this query is a lot easier to read. So we can say, so employee last name is Johnson, and employee first name is equal to Steve. So now our query makes a lot more sense. We're going to select from customers. We're going to join the employees, employee ID by employee ID, last name, where last name Johnson or first name Steve. If we just don't select this filter, just run the query, then we're going to see a list of all employees with their list of all the customers with their associated supporting employees. So what we can do with the data, we can right click and export data. Put the CSV format. Next, next, and next. Then you'll pick which folder you want to put it in. Click proceed. Now we got the file that we just exported. I'll rename it to employees. It's customers, for example. I right click new Excel. And I'm going to get our data, get data from file, and pick the source, transform the data. Let's say we like everything here. File, close and load. So now I have a table in my Excel. Let's say I want to create a pivot table. Insert pivot table in your worksheet. I want to get my employee last name, employee first name, and then I want to have count of employees, count of customers per employee. You can go to design, this not show subtotal. So we just built this pivot table. We can see that Steve Johnson supports 18 employees, Park Margaret supports 20 and Peacock Jane supports 21. If we will click on it, we get the list of customers. What I want to be able to do is to get this data from SQL without going to Excel, just to get this type of data from SQL, which we're going to do next. So let's try to build the same pivot table in SQL. So what type of fields we're grouping by? Employee last name, employee first name, and we aggregating the sum of customer IDs. So let's try to do it. So first let's, from this join that we have, let's select only fields we care about. So we care about employee last name, employee first name, and customer ID. No other fields we're interested in. So now let's kind of do it manually, step by step. Let's order it by employee last name, employee first name. And run this query. So now you can see that we kind of build groups. Johnson Steve has these customers, 18 customers. So if you look at our pivot table, Johnson Steve has 18 customers. And if we double click, we can see these customers, 57 to, let's order A to Z. So we can see 267, 267, so we can see that we look at the same data. So now what we want to do is we need to group these groups into single row, Johnson Steve into single row, and instead of customer IDs, we're going to display sum of customer IDs. So in SQL, it will mean group by statement, group by last name, last name, first name, and now we need to remove this customer ID because we're already grouping into one row. So instead of customer ID, we will count of customer ID as customer ID count. Let's try to run this query. And then, once we got this grouping done, we're going to order it by employee last name and first name. So now let's compare the data we got from SQL versus the data we got from our pivot table. Johnson Steve 18, Park Margaret 20, Peacock Jane 21. We go back to our pivot table, 18, 20, 21. So the same data, same grouping. So now we can export it into CSV files. So instead of, if all we really cared about is to get this pivot table from the data, and the data can be millions and millions of rows, then we could just use SQL and we get the same data as we got from a pivot table. So let's continue our exploration. So we learned about our employees, about customers. Now invoices. You see this dot next to invoices, meaning that one customer may have multiple invoices, which would make sense. So how is it related to? If you click on this relationship, customer ID, customer ID. So each invoice has customer ID, and customer ID is described in customer in a customer. Right? So let's create another script. New script. Again, I'm going to rename it to invoices. And let's do select stuff from invoices. Invoices. So we don't have a very large database. 412. If you want to see how many records we got, we can just use down star and it will tell us 412. So we aggregate against the whole row, against the whole result. Okay. So we have invoices. Invoices have customer ID. Invoice has primary key, invoice ID, customer ID, and we're going to join our invoices with customers. So let's first pull the data that we care about from invoices. So which kind of we're interested in? Invoice ID, customer ID, invoice date, okay, will be address we may not need, city, state, county, postal code. Okay, well, it's not very interesting because customer has address, right? So, but total, that's interesting. So let's run this query. So now we have less. So now I want to add information from here. So if you go look at tables customers. Okay. So I want to add customer name, first name for each of the invoice, city, state, city and state. So what I'm going to do, I'm going to join. So invoices, let's call it alias I. I'm going to join customers C on. Now I dot customer ID equal to C dot customer ID. And now what I have to do is each column that I get from invoices I'm going to prefix with I. So I know. So if we have duplicate names, they will not collide. Total. Now we can do customers. What kind of fields we care about customer? We don't need to repeat C customer ID because it will be equal to I customer ID. C first name, C last name, C city, state, okay. Supported rep ID. Let's try to get this information. So now, if I want to find all invoices for customer with last name Hansen, I can do my where clause, where customer last name is equal to Hansen. Let's see. Okay. So now we can see that customer Hansen has 7 orders from us. That's already interesting. So that's very interesting. Now I want to add to this query information from the employee, supported employee. So before I do that, let's rename this first name, last name as customer first name, customer last name, customer first name, customer last name. So now to this data set, I'm going to join our table employees on employee ID equal to customer support rep ID. And I can add to my result set information from employee. Employee last name, employee first name. Employee reports to. Let's say that. So let's run this query. Okay. So that's an interesting data set which we're going to export and analyze in Excel. So we're going to right click, export data, CSV, next, next, next. So where is it going to go? Okay, proceed. Done. So now that we go to a database, to our directory, we see this file. I'll rename it to invoice data. Now let's import it into our Excel file. New Excel worksheet. Invoice data. Let's open it. Data. Get it up from file. CSV. Invoice data. Transform. Let's see what we have. ID, invoice date. Okay, that'll be date time. Date time. Let's just make it just pure date. It doesn't like it. That'll be date time. Our total, we want to be a currency. Customer name, first name, city, state. Last name reports to. Okay. Close and load. Okay, so we got our table. So what I want to do is I want to get customer, first name, last name, and group it with sum of the total amounts. So we're going to insert our pivot table. Pivot table. So we're going to get our customer last name, customer first name, and we're going to get total. We'll make it the sum. First name, last name. We're going to change the design. Do not have subtotals. Okay, and we can and we have a pivot table of totals for each customer. Another interesting thing would be to count of invoices. So we're going to get count of invoice IDs, and we can see that for this customer has 7 invoices. Double click. Here's the 7 invoices. Here's the amounts. Looks like our data has all 7 invoices. Not very real, but okay. Well, let's try to create the same pivot table in SQL. So data we need is customer last name, customer first name, the amount, and invoice ID. So we're going to go to what takes this query. What we're interested in is customer first name. Actually, first customer last name. Last name. Then customer first name. Invoice ID. And a total. Okay, so now let's order it. Last name, first name. We don't need addresses here. Okay, so now we have our groups. So here's the first group. Here's the second group. And so on and so forth. Now we're going to aggregate this group into a single row. So we're going to do group by these 2 columns. And now we need to aggregate these 2 results into a single result per group, which here will be count. And here it will be sum. And we're going to call this field, let's say that's total. Invoice count. So let's try to run this query. And we can see for Amanda Roberto, we have 7 invoices at 3762. Let's look at our Excel. Amanda Roberto 3762 7. Barnett Julia 4362. 4362. So we know that grouping worked. Again, we would prefer to do this grouping in SQL instead of Excel if the amount of data is very large, and just pull this data from a database already grouped instead of doing it in Excel. Okay, let's keep exploring our database. So we explored employees, customers, invoices. Now you can see invoice items. So one invoice may have multiple invoice items. So inside invoice items, we see truck ID, unit price, and the quantity. The trucks are really songs, right? So unit price is how much it costs us, and the quantity. So sum of unit price times quantity should be equal to the total on the invoice. We can check that, make sure that our system is correct. So what we're going to do is we're going to join our invoice items to our invoice query that we already built. To do that, we're going to create new script. We're going to call that script 04 invoice items. So we're going to copy our query from invoices. So I have it handy. But I'm going to start. Just let's look at invoice items. And you can see that we have quite a few. How many? Let's look. $2,240. That's pretty good. So let's see, since it's a very large amount, not very large, but kind of. Let's put limit. So say don't give me everything, just give me first 10 items to look at. Okay, so what you see here is we have invoice ID, truck ID, unit price, and quantity. So if I want to find all invoice items where invoice ID equal 1, this will give me missing database, no such common invoice ID. Okay. Invoice ID equal 1. We don't need limit from here, so we can see that invoice 1 has 2 line items. Unit price is 09 and quantity 1. So we have 2 items. Two different truck IDs, 2 and 4. We can have invoice unit price. So let's look at invoice. Where ID equal 1. So we expect 198 to be unit total, right? If everything is correct. Where invoice ID equal 198 total. So if we run these 2 queries, here's the items that are part of this invoice. 2 items, 198 total, two items, and come from this invoice total is 198, and we can do sum of unit price times quantity, right? Just to double check the data is correct. It gives us 198. So what we want to do right now, we want to make sure the data is correct, that all the sums of invoice items are equal to the total of the invoices. Make sure the data is not corrupted. How do we want to do that? So we're going to do invoice line item ID. We're going to select invoice ID, quantity times unit price as line total. Okay. So now what we're going to do is we're going to also join our invoice ID equal invoice item invoice ID, and we're going to select invoice total, and we can call it as invoice total. Ambiguous invoice ID. Here, which invoice ID? Doesn't matter which one, but let's call it from invoice ID. Here is also. Okay. So invoice total 198. Line total is this, right? So what we want to do is we want to compare the two. How do we do that? We have to group. Instead of having these two records, we're going to have one record. So let's order by invoice ID. So now you can see that here's items from invoice ID 1, here's items from invoice ID 2, and so on and so forth. So I need to group by invoice ID and sum line total. I also need to get rid of duplicate in invoice total, so I'm going to do maximum minimum. It's going to be the same. For each invoice, each line will display the same number because it comes from invoice total. So let me create a grouping. Group by invoice ID. So line totals, I'm going to do sum of this value as sum line total. This one I will do minimum value as invoice total. Minimum. Okay. Now, just visually, it looks like we have data is correct. Sum of line item total is 198 and invoice total is 198. So, but that doesn't mean that this is correct for all invoices. We need to figure out for all invoices. Well, you know how to do that. All we have to do is export it to Excel, right? So we're gonna go to export data, CSV, next, proceed. We're gonna go to, we're gonna rename invoice line items.csv. And now we can create new worksheet. .excel. From file, we get our data, invoice line items. Okay, this is ID. We can change this to currency. And this one to currency. We can close and load. So that's pretty good. What we can also do is data edit our connection. We can do add column, custom column. And here we can say sum of line total is equal to okay. And we can actually see right now that they're all true, but that's okay. Let's close and load. So now we can filter our database, our table, everywhere it's not true, they're all true. Right, so if I will filter it out, so they're all true, it means that our database is consistent. If one of the line items, some of line items would not be matching to invoice total, we would have a record where it would not be true. So we just validated our database. Okay, now let's build another query that actually joins invoice items, invoices, then customers, employees, all together. So first we're going to do select start from invoice items. And since we may have a lot, we're going to leave it 100, let's say like that. Okay, let's see which columns we're interested in. Invoice ID, track ID, unit price, and quantity. Okay, so let's do invoice line ID, invoice ID, track ID, unit price, quantity. In this particular case, everything is interesting. Join invoice ID equal II invoice ID. So we're joining invoice ID to invoice ID. Now let's see which columns are interesting for us from invoice. Customer ID, total is not interesting because we can calculate it from unit price and quantity. So mostly what I'm interested is invoice date. That's interesting. Maybe billing postal code. So let's try to see if it works. Now we're going to join this result with our customers. Customer ID equal to invoice customer ID. So now let's pick which fields we're interested in from customers. First name, last name, city, county, state, maybe company. Let's make sure it still works for us. Now we want to join this. Employee, join employees, employee ID equal to customer support rep ID. So now what kind of information we want to have from employees? Employee last name as employee last name, employee first name as employee first name. And employee first name. Okay, so now we're basically getting data from 1, 2, 3, 4 different tables. So let's see this name as customer last name as customer city, customer country, state, company. Okay. Customer first name. Okay, so we got quite a lot of information, which now we can export that to Excel and do analysis again. So the most interesting thing is about track ID. So now we can see what track, which songs, right? So we may have information which songs are sold the best based on this information, which track IDs. And we can start looking at how we're doing for our customer city, but the item basically gives us information about track IDs that we can already start collect intelligence on. Okay, so we kind of learned about our invoice items, and we can see that invoice items have track ID, which relates to tracks. Tracks are basically name of the song. So let's connect tracks, and we can see track and tracks, as you can see, related to albums and albums related to artists. So let's try to connect all these all the way from employees to item, to tracks, to albums, to artists. Or also tracks are reflected with genres and media types, and tracks are part of playlists. So we're going to go connect all these tables in the next query. Okay, let's create a new script. And we're going to rename it into tracks. So we're going to do select star from tracks, so we can see what kind of tracks we have. So we have a name, album. Let's look at our ER diagram. So tracks connected to album and album connected to artists. So let's see what is in albums. Let's start from album. Albums. Okay, and albums collected to artists. So we will start again from actually line item, invoice line item, which is in our previous query. That's for our reference. From invoice items, we're going to join track. So let's list what we're interested in. Invoice line item ID, invoice ID, track ID, unit price, quantity. Let's get all these fields. So now I'm interested in to join tracks. Track ID is equal to invoice item track ID. And the information I'm interested from here is name of the track, composer, that would be interesting, composer, unit price. Okay. We have unit prices already on our invoice item, so not interesting. So we're going to join our tracks. If you look at our ER diagram, to albums. So we go back to this query. Album ID equal track album ID. So which information are you interested from album? has album title, and we're going to be interested to join artists. Artist ID equal to album artist ID. Artist name as artist name. So let's try to see what we have. So we have artist, AC/DC, album, title, the composer, the name of the track. Let's call it, so it will be easy to understand. Track name, quantity, invoice unit price, track ID, invoice ID, and invoice line item ID. So now we have invoice items. Now we would be interested to join it with invoices. Equal to invoice item, invoice ID. So what information we want to select from invoices? Invoice date, that's pretty much enough. Now we want to join customers. Customer ID equal invoice customer ID. Information we want to get from customers. Customer first name, customer last name, customer state, customer country. We need to put here as customer first name, customer name, state, customer country. So now we can see more information. So we still can join another table, which is employee. Employee ID equal to. So we're going to join with customer support employee, support rep ID. And what kind of information we're going to get from customer, from employee, first name, last name, and an employee, reports to. So let's call this okay. Let's for now remove this. Make it simpler. Okay, so now we have pretty large data set that pretty much join most of the database. We can export this data into CSV file and do analysis. So let's do that. Proceed. Let's call it tracks track data.csv. New actual Excel. Let's go import data. From CSV. So we can transform data. ID, track ID, unit price, input currency, quantity, column name, invoice date, date time. Okay, looks good. Close and load. And here, for example, we have data about our artists, and we can see let's get some sales per artist. So let's insert pivot table. So let's make artist. This is our artist. What we need to get is unit price and quantity. So let's just do counts for now. Count. Sort. And we can see the count for sales. It's the most popular is Iron Maiden. Then U2, then Metallica, then Led Zeppelin, which kind of makes sense. And let's see album. All right, now we can see we can actually go with albums to be first and remove the artists. Or even more interesting, artist name. Yeah, let's do it this way. So we have artist, album, and their sales. So this is going to be the end of the class. So we covered quite a lot of information. Next, we'll be learning more about analytics functions.